It is a debate that has troubled physicists for more than a century. It is a gaping hole in our understanding of the world. Currently, there are two theories that describe how our universe works: the standard model of quantum mechanics and Einstein's theory of relativity. Quantum mechanics describes our universe on a very small scale, while relativity describes it on a very large scale. If you try to describe anything small using relativity or vice versa, you run into serious trouble. But does the universe really operate according to two different sets of rules? Is there a single theory that could unify the two incompatible descriptions of our reality? Well, allow me to introduce you the string theory. String theory states that all of the tiny particles that make up an atom are composed of tiny vibrating strings. These strings vibrate in one way or another, and different types of elementary particles are just different modes of vibration patterns of a string. We can think of string theory as me playing the piano. As I play, the hammers strike the individual strings, causing them to vibrate. Each key on the piano is able to make a unique sound because each string vibrates in a unique way. In string theory, each note on the piano would represent one type of elementary particle. So how come we have never seen those tiny strings through a microscope? Well, that is because the strings are so tiny that no microscope is powerful enough to see them. A length of a typical string is 10 to the negative 33 centimeters. That distance is known as the Planck length. If an atom were the size of the Milky Way galaxy, then a string would be the same length as the thickness of a piece of paper. But what is truly amazing about Planck length is that it can be expressed using this equation. The h with a little bar on it is the reduced Planck constant, a number used in quantum mechanics. G is Newton's gravitational constant, and c is the speed of light. This equation unites three of the most fundamental constants in physics. String theory also explains how different particles interact. Take the repulsion between electrons as an example. When two electrons approach one another, one electron shoots out a photon and the other absorbs it. As this happens, the momentums of both electrons are changed. According to string theory, creating a photon can simply be seen as cutting that string into two separate pieces. The absorption of that photon by the other electron then can simply be seen as two strings joining back together. Nevertheless, like all of us, string theory isn't perfect. We humans live in what's called a four-dimensional space-time, while string theory's equation needs a mind-blowing 10 dimensions in order for it to work. Also, string theory has no experimental or observational proof. Despite its downsides, string theory remains one of the most promising candidates for a theory of everything. Even though some may deny the legitimacy of string theory, there's no denying that the universe is an amazing place. Thanks for watching.